Yes, Sasrika students. So we are here once again, lecture number 2, Work and Energy, class 9. We've already understood what is work. Work is force times distance. We also know the unit of work. Any student?
Joule.
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 Beautiful. Uh, we also know how to define one joule. It's basically one force of 1 Newton acting on a body so that it is displaced by a distance of 1 meter, then the work done is said to be 1 joule. Am I right, students? Oh, that's good. So we know what is that. Okay. Now we also know what is 1 Newton force. Now comes what is energy, the main thing. There's no energy. Very simple, students. There's no work. If there's no energy, there's no work. A weak person cannot do any work. Why? Because his muscles do not have energy. Okay. Now, what are the types of energy? Students, there are so many types of energy. Can any student tell me some types of energies he knows? Yes,
So
student.
mechanical energy,
Okay, mechanical energy.
Chemical energy.
One second. Mechanical energy. Okay, that's good. It's right. Mechanical.
Chemi
The second one is yes.
Chemical energy.
Okay, that is chemical energy. No, that's true. Any other energy you know? Have you?
Sound energy.
Kinetic energy.
Okay, I was looking for this answer. This is right. So, students, I was looking for this answer. Kinetic energy. And you must have heard about potential energy also. Students, kinetic energy and potential energy
Yes, sir.
yes, sir.
together known as mechanical energy. The question is why? I'm not just going to teach you this subject. I'm also going to help you understand why. Chemical energy. Then any other types of energy? There are so many types of energy.
Heat energy.
Okay, beautiful. Then nuclear energy.
Electric energy,
Anji, which one?
electric energy,
Yes, that's really true. Beautiful. That is electrical energy. You see that electrical energy, anything which can do a work has energy. Now, what is electrical energy? You see, students, if you touch electrical wire, you obviously you will not understand what is electrical energy, but after your death, other people can understand what is electrical energy. Such a shock you can get. It can throw you out. So yes, it has energy. Chemical energy, the example is our battery. Everyone has inverter is related to battery. It can do work because battery gives out gush of electrons, and then that moving electrons is known as current. Motion of electrons per unit time, and you know that it can move your fans. It's doing work. It can light your bulbs. It can do the work. So it can drive motors. It can drive the self in the automobiles. It's a chemical energy which can drive the self in automobiles. When we start our car, okay, the car is now not started on by engine. The car is started by battery. That is chemical energy getting converted to mechanical energy. See, students, nuclear energy. Example of nuclear energy: bombs, nuclear bombs, hydrogen bomb, atomic bombs, nuclear energy, a lot of energy. The elements like uranium, thorium, they have a lot of nuclear energy. Heavy metals, we call them heavy elements. So guys, we have so many types of energy. We also have rotational energy. Do you know that, students? The rotational energy is possessed by any particle or any body owing to its rotation about axis. It has a rotational energy also. And then, students, I'm not remembering, but there are so many types of energies, translational energy, lot of energies. Guys, in this chapter, we are going to focus on kinetic energy and potential energy, right? Together they are known as mechanical energy. Okay, so let's understand what is kinetic energy and what is potential energy. All right, guys. Now, student, tell me, you have, let's say you see a revolver and they shoot a bullet from the revolver. The bullet can kill a person. That's a work. The bullet can pierce through a thin sheet of metal. That is work. The bullet can, do a lot of destructive things also. So that is work. So that means bullet has a lot of energy. Now let us understand that what kind of energy bullet has. What kind of energy bullet has. So, students, interesting thing. I'll give you more examples. You see, you know about windmills, students?
Yes,
Windmills
sir.
are the mills, they have turbines and a lot of other parts, and they convert the movement of air when the air is moving through the these blades, the the motor is rotated and electrical energy is produced. So you can say the motion of the air is tapped. So air is moving here, bullet is moving. All right, air is moving, bullet is moving. So also, students, if imagine if a car is moving, you know and another car is also there, so they can collide. A car can burst into a house, break the entire house. So car has a lot of energy. Okay, if you talk about some other examples, students, imagine that you you are, uh, let's say there is a, let's say on the bottom, there are few tiles you have attached. Okay, what is that, students? Few tiles are there. Okay, you have attached here. Only two or three layers of tiles are there. They're not very strong. And let's say there's a building. There is a building. Now you are there on the third floor of the building. On the third of the floor of the building, you have a sphere. Let's say you have an iron sphere. You drop that sphere, what happens? So many bricks are, if you drop the sphere on this tile,
Broken.
so many
Broken.
broken, beautiful. But students, what happens if you take the same sphere? You see, mass is not changing, nothing is changing. But if you take the sphere on 10th floor, what will happen? And you drop, how it will be different in the first case? Any student?
Difference of height. If it will be on the 10th floor, then it will be more destructive
Oh,
than the older one.
oh, that is beautiful. That's a a creative way you are learning. It will be more destructive. Now, the mass of the sphere has not changed, but the energy of the sphere has changed. Why it is more destructive? Because on 10th floor, maybe the energy possessed by the sphere is more. Am I right? But the sphere
Yes,
is,
sir.
not moving. No, here it is moving, I agree. But just by taking the sphere on the 10th floor, see, in this case, bullet is moving, car is moving, wind is moving. Okay, they have energy. But if I just place a sphere on the 10th floor, it's not moving. Then how because of height it has more energy. Okay, now one example. Second example is, students, Joule's experiment. Joule's experiment means a great experiment done to demonstrate that heat is a type of work. So this was insulated chamber. Here there was some stirrer. There was some stirrer, and students, here there was a pulley. From the pulley he dropped masses. What he did? He dropped masses. So suppose he dropped mass first from this much height. When he dropped the mass from this much height, what happened? It rotated. When the pulley rotated, this also rotated. When he dropped the mass from this height, the rotation was less. When he dropped the mass from very small height, the rotation was very less, and hence change in temperature was also less. He was actually trying to relate work and heat. Temperature is related to heat, and dropping a mass from different heights, h1, h2, h3, is the work he is doing. So students, tell me, if I drop the mass from more height, is it doing more work or less work as compared to if I'm dropping the mass from lesser height? Any student can tell me? When the height is more, the work done will be more or less? When I
More.
drop, correct, very right, Pranav, it will be more. So many examples I have discussed. I have seen what? That in the first case, the energy is possessed by bullet, by the motion of air, and by the car moving. They are all in motion. They are all having some velocity, right? The energy possessed by a body, energy possessed by a body because of its motion is known as kinetic energy. So students, the faster some body is moving, more kinetic energy it has. If a body is moving slowly, it will have less kinetic energy. Kinetic word is actually related to kinetic, dynamics. Kinetic means motion. Change in position is the meaning of kinetic. So kinetic energy of a body is related to its motion. Interesting thing, units. Students, the unit of energy is again joule. Energy is, whether it is kinetic energy, potential energy, rotational energy, any energy, it is measured in terms of, the definition is capacity to do work, is the measure of what? Energy. If the capacity to do work is more, we can say object has more energy. But which energy? It can be kinetic energy, it can be potential energy, it can be different forms of energy. Okay. If a current flowing in a wire is 5 ampere, it can do some work but less as compared to the wire when 50 ampere current is flowing through it, because it has more energy, more current, more energy. All right. So guys, energy is capacity to do work. Unit of energy is joule, you know. And how do I define, students, 1 joule of energy? You can say 1 joule is energy required to do 1 joule of work. Can you speak again with me? What is 1 joule of energy? 1 joule, object is said to have 1 joule of energy if it can do 1 joule of
Work.
Work. So, suppose the energy possessed by a body is 100 joule. What does it mean? It means it has the capacity to do how much work? It has
100 joule.
100 joule of work. Beautiful. All right, guys. Kinetic energy is clear to you. Now I will also tell you, but cannot derive because there the knowledge of molecular level, atomic level in chemistry, in physics is required of gases. So that we will do later on. So kinetic energy of an object is basically half into its mass into what? Kinetic energy is because of any student? Kinetic energy is possessed by a body because of what? Because of
Motion.
motion. So what?
Velocity.
Yes. What is the parameter which decides the motion? Velocity. So whatever is velocity, square of the velocity, students. Remember always, kinetic energy is half mv square. All right. So students, can we do a small numerical? Let's say we have a body at having mass 10 kg. Okay. The velocity is also 10 meter per second. Can any student tell me what is its kinetic energy? Fast.
500. 500.
What? Any student which speaks without units is not a good student. So half into mass is 10 kg into velocity is what? Velocity is 10 square. So that is equal to, this is 5 into 100 is 500 watt. What is this? What is the unit of kinetic energy? No, Newton is
Joule.
unit of force.
kg meter per second.
Joule.
This is joule. Now students, I am going to talk about how this is joule. You know, let's go a little bit more in depth. Yesterday we had understood, student, joule is a joule is a unit of, yesterday we had studied, joule is the unit of, tell me, joule is the unit of, yes,
Work done.
work done.
Work done.
So that is force into distance. What is the unit of force? 1. Tell me, students. Tell me. Force is 1.
Newton.
And what is the unit of distance?
Meter.
Kilometer.
Okay, but in SI unit, you know, in SI system, it is not kilometer, it is meter. Okay, so Newton into meter. Let's break them further. You will enjoy, students. You will come to know, I think in the mind of some students it came, how it is joule, sir. This is in kilogram and meter and second. Am I right or wrong, students? Did it come to your mind?
Yes, sir.
Joule.
Yes, sir.
Oh, you're going to enjoy in 2 minutes more. Now let's split Newton. What is Newton? By second of motion. Newton is equal to mass into force. Newton is force. Force is equal to mass into
Acceleration.
Velocity.
beautiful. These are the basic units. So can I express Newton in terms of mass into acceleration? What is the unit of mass? In SI system, unit of mass is, come on,
kg.
kg into what is the unit of acceleration, Mansimrat Kaur? What is the unit of acceleration?
Meter per second
Meter per second.
square.
Yeah, beautiful. Into, this is the unit of Newton, am I right? Kg into meter per second square into, this is again, this is the force. This is force. Force into distance, that is meter. So what is the unit total? What is the unit of work done? Work done is force into distance, kg, then meter square divided by, tell me, kg meter square. Meter into meter is meter square divided by
Second square.
second square. All right. Now, how we can say that half mv square, half mv square is what? Half mv square is kinetic energy. Am I right, students? And just now I told what is the unit of energy, whether it is kinetic energy, potential energy, gravitational energy. Oh, see, one more type of energy, gravitational energy.
Joule.
What is the unit? Joule. We want to
Joule.
one rose, it's coming as joule. See, half, what is the unit of half? Half is a constant, no unit. Leave it. What is the unit of mass? Kg into, what is the unit of velocity? V square. What is the unit of velocity? Meter per second. And I will do
Second.
square of this. Why? It is mv square. So this is equal to, so interesting, kilogram into, tell me, it will be meter square divided by,
Second square.
are you guys getting excited? See, this is the unit of kinetic energy and this is the unit of, kg into meter square per second square is the unit of,
Work done.
oh, by the units also I have proven that work done and energy have same, come on students, same unit. And what is that unit
Unit.
in SI system? In SI
Joule.
system, that unit is joule. All right. So now guys, I talk about potential energy. And I will also tell you why potential energy is equal to mass of a body into its acceleration due to gravity into HEGIH, height of the body. You see, students, you remember Pranav said, sir, if you drop the ball from here on the tiles, okay, it will break the tiles. But if you drop the ball from here, there will be more destruction. Why? Because height has increased. This is H1 and this height is how much, students? Let's say H2.
H2.
H1 is greater than H2.
H2.
Now, what is the unit of potential energy? M, mass is M, acceleration due to gravity is G, and height is H. Always remember, students, potential energy is mgh. But will you not ask me, sir, how this formula came? I can explain you. Will you not ask me, sir, how this formula came? It's difficult to
Yes, sir.
Sir, please explain.
Sure, it's difficult to explain this formula because atomic level the jankari tan chahiye. You know, it's like the energy possessed by every atom or every molecule of a compound. You know, so that's little bit difficult right now. In ninth, like, you know, few months or few years later, I will explain. But this is very easy. Shall I explain? See, students, how a object gets potential energy. How object gets potential energy? It's very strange, students. See, imagine there is a sphere. What is this? This is a, come on student, this is a sphere of mass
Here.
m, and the unit is kg, right? Now, how this sphere gets units? Imagine this is the surface of the earth. What is this? This is, come on students, tell me. This is surface of,
Surface of Earth.
we imagine, actually it's not true, but we imagine here what is the height? H is equal to 0, though it's not true, because you cannot take even the surface of earth as datum, because this sphere, this whole universe is so large. There's so much of negative height below the surface of Earth also. Anna, we can't take it as absolute height, but okay. For the ninth class students, we can take h is equal to 0. Now students, what I do? I take this sphere here. Now students, can I take this sphere here? Monroe's. Monroe's is there? Hello Monroe's. Students, can I take this sphere from h is equal to 0 to h height without doing any work on it? Without any work done?
No, sir.
I can't do. I have to do some work. Now, students, can anyone tell me that how much force I have to apply to lift this sphere? See, yesterday, a few days back, we had discussed the weight of any body is always directed towards the, remember?
mg.
No.
Center of the earth.
Center of the earth, yeah, because some student had used downwards. So I told you, if earth is here and if suppose a body is here, downwards means this? No, towards the center of the earth. All the bodies on the surface of earth, even if the body is here, all the bodies on the surface of earth, their weight is always towards the, this point O is the center of the earth.
Center of the earth.
Oh,
This weight is acting downwards, am I right? This weight is acting downwards, am I right?
yes, sir.
Now, can you tell me how much force I have to apply in upward direction to lift this sphere? This is the force acting downwards, mg. Let us say this is 100 Newton. In order to lift this sphere, how much force I have to apply? Minimum. Can any student tell me? Okay, don't worry. I will make you think. Imagine students,
Sir,
imagine, wait a minute. Suppose this is something. And a person is pulling it with a force of 50 Newton. There's a person. Here there's a person. If you don't want this block to move, how much force you have to apply in the opposite direction so that it doesn't move?
50 Newton.
So why don't you answer? See, now if the force acting downwards, the weight of this sphere is mg, then how much force, minimum force I have to apply to put it up?
More than mg.
Little bit more than mg, very right, but you can say almost equal to mg, right? If I apply this force and if I, with that force, if I take this to how much distance, it will come here. How much distance I will take? To the distance of, vertical distance of
H.
Now, how much is the work done in this case? Work done is always force into displacement or
Distance.
right? Now, how much is the force applied, Sargun? Upwards.
M.
Mg. And by how much distance it is lifted?
H.
So this is the work done on the sphere. And you know, students, I'm applying engineering here. This work done, strange. Where this work done goes? This work done is stored in the sphere in the form of which energy? This work done is stored.
Heat energy.
No, it doesn't get
Potential.
in the form of potential energy. That's why The unit of potential energy is mass times acceleration due to gravity times height. Did you understand? Did you enjoy, students?
Yes, sir.
Maybe you
Yes, sir.
again and you understand better. So potential energy also we have done. Now students, last thing, calculate the potential energy of a body. Its weight is equal to 50 Newton and the height at which it is placed is 10 meters. This is the height at which this weight 50 Newton is placed. There is some weight 50 Newton, it's placed at this much height. So can you calculate the potential energy of this body? Anyone? How much will be potential energy?
Can I say
Yeah, speak. Recording is going on. Don't waste time on calculating.
500 joules?
Beautiful. It will be 500 joule. Why? Because potential energy is mass into G into H. mg is the weight of the body. So that is 50 into H is 10 is equal to 500 joule. And again, students, unit also you can understand mgh. Now let us see whether the unit of mgh, how it is joule. But before that you should understand what is the unit of work done. Work done, it was kg into meter square divided by, see that before we have derived it, you forgot so soon. Work done,
Kg into meter square
Meter,
upon
meter
second square.
square per second square.
sorry, not centimeter, second square. So students, this is kg meter square by second square. And what about mgh? Is it coming to be the same unit? What is the unit of m? M is mass. Mass is kg. What is the unit of g? G is acceleration meter per second square. What is the unit of h? H is height. 500
Meter.
in meter. Wow, students. It is kg meter square by second square. That is also equal to Newton into meter. That is equal to joule. So students, the potential energy is equal to mgh. Okay, students. One more thing, students. This is a book of a student. What is this? This is book of a student. Okay. So what happens? There is a let's say this is a building, right? So uh, you know, there's a student who throws the book, and this is ground floor. Here is another student, his friend. He catches the book here. The book flies down by a height of, let's say, 4 meter. The mass of the book is 500 grams. Students, can you tell its change in potential energy when it is dropped from this position 1 to this position 2? Can you tell its change in potential energy? It's an interesting sum. So student, this is the ground, right? This is the ground. First, we will calculate the potential energy of the body at this height. So let us say this height is h. So can you tell me what is the potential energy of the body at this height? Here we will take the height from the ground.
6 meter.
Uh, no, this is h. H, students, h. This is not 2 meter. This is position 2. From position 1, the body is dropped or dropped to position 2. This height is h and this height is 4 meter. So what is the total height, students? From here to here, it is 4 plus h meter. This height, see students, very simple. This height is 4 meter and this height is h. So what is total height?
4 plus h meter.
What is the potential energy of this body? Potential energy at 1 is equal to mgh. Now what is the mass? 500 gram. Convert the mass into kg. So it will be half kg into, let's say, g is 10. H is how much? 4 plus
40 plus H.
h. Not 40 plus h. 4 plus h. Why you said 40?
Okay.
Why you said 40?
Oh, sir, I
Say 40. Okay.
didn't see.
Is the potential energy of the body at point 2. Again formula mgh. So what is m? M is again same. What is g? 10. What is the height? H is h. Height is h. So this is equal to 5h. Am I right? Now what is change in potential energy? Let's say this is P1, this is P2. So change in potential energy is P1 minus P2. That is equal to how much? This is 2 ones are 2, 2 fives are 10. So this is 5 into 4 plus h minus 5h, right? That is equal to 20 plus 5h minus 5h is equal to 20 joule. Is that change in potential energy? We can
Potential
also
energy.
calculate very simply. Change in potential energy is equal to mg h2 minus h1. So this is equal to, what is mass? Half. G is 10. What is h2? h2 is 4 plus h minus h1. h2 minus h1. h1 is h. So this is equal to 5 into 4. That is equal to 20 joule. Did you enjoy, students? How was the lecture?
Yes, sir.
Very
Very interesting.
I request you to share with your friends and see it again. And I really expect that you ask doubts in the form of comments. I would love to answer. Thank you very much.